In this lesson, we are looking at volume, which refers to the amount of space that an object takes up or the amount that the object could hold. So we could also think of the volume as the capacity. They're basically the same thing. So in the first example, we are asked to find the volume of this given sphere. Now, you don't need to memorize the volume formulas. You can ask me for the formula sheet if you don't already have it that has the volume formulas on it. Okay, so the volume of a sphere then from your formula sheet is V equals 4 pi r cubed divided by 3. Now just pay attention to the fact that in the question it's actually the diameter that you're given. So the radius in this question would be half the diameter, so 25 centimeters. All right, so let's put 25 in for r in your formula. And if you type that into your calculator all at once, you'll get a volume of 65,449.85, and the units would be centimeters cubed. So volume units are cubed, whereas area units are squared. Now, then it says convert the volume we found in example 1 to cubic feet. So let's go back and remember the relationship between feet and centimeters. So on your conversion charts, you should have a conversion from feet to centimeters. And it's 1 foot equals 30.48 centimeters. So if we are interested in cubic feet to cubic centimeters, what we could do is cube both sides of this equation. So 1 cubic foot would be 30.48 times 30.48 times 30.48 centimeters cubed. And if we type that into the calculator, we find out that 1 cubic foot is 28,316.85 cubic centimeters. Now we are interested in converting 65,449.85 centimeters cubed into cubic feet. So our answer from example 1. So then if we take that number, and we know that every 28,316.85 centimeters cubed is 1 cubic foot, then we would want to divide by that number to see how many cubic feet are in our sphere. Okay, and when we divide that out, it is about 2.31. So therefore, the volume is equivalent to 2.31 cubic feet. Okay, now if you're finding the volume of a prism or a cylinder, there is sort of a general formula that works. You can also use the formulas on your formula sheet. But in general, the volume for a prism or a cylinder can be found by finding the area of the base and multiplying that by the height or the depth. And I say the height or the depth because it just sort of depends how your object is sitting. So if we looked at this first example, okay, looking at this as this is a prism, this is a triangular prism. The base is actually the triangle in this shape. It's not necessarily the side that it's sitting on. So the base of a prism is the polygon that's at the end of the shape, not the rectangular sides that connect them. That's what makes the shape a prism, the fact that you've got two polygons, meaning these two triangles, okay, two polygons, connected by rectangles. That's what makes this shape a prism. So when we talk about the area of the base, it's actually one of the polygons on the end that we're talking about. Okay, so if we find the area of this triangle and multiply it by, in this case, I would call this the depth. You can think of it as the height as well, but it's not really sitting up on its base, so it depends if that confuses you or not, okay? But if we take the area of the triangle and multiply it by that number, we'll get the volume. Okay, so volume equals the area of the base, so that'll be the area of the triangle, times 8 centimeters. Now the area of the triangle is found by taking the base times the height, meaning the base of the triangle, not the prism. So 4 times 6 divided by 2 will give us the area of the triangle on the end. And then we want to multiply that by 8. So this would be 12 times 8. So the volume is 96 centimeters cubed. Okay, that concept works for cylinders as well. So when looking at a cylinder, the volume would be, again, the area of the base, which is the circle, times the height. So a cylinder is not a prism, but sometimes they're grouped together because of the fact that a cylinder has the same shape, top and bottom. So it has two sort of parallel circles, connected though by the rounded edge on your cylinder, which is what differentiates it from the prisms. But when it comes to calculating volume, we can think of them the same way. So the area of the base here would be the area of the circle, which is pi times r squared, so pi r squared, times height, so times 7. So the volume is 269.39 centimeters cubed. Okay, next example. A hockey puck has a diameter of 3 inches and a height of 1 inch. A cylindrical container holds a stack of 4 pucks. What's the minimum volume of this container to the nearest cubic centimeter? So we have 4 pucks that are stacked on top of each other here in a container. So 1, 2, 3, 4. So we have some choices here. If we want to find, now it says the minimum volume. That just means assuming that there would be no space between the pucks and the package, what would the volume of the package be? So the container may be slightly bigger than that, but it would in the very least have to be the same size as, or very slightly bigger than, 4 pucks stacked together. Now when you're finding the volume of a composite shape like that, you could find the volume of the pucks individually and add them together. So you have some homework questions where that might be useful, where you've got 2 shapes stacked together and you need to find the volume. So you could find the volume of each one separately, then add them. Or in this case, you could just find the volume all at once by figuring out your dimensions. So for example, your diameter here is 3 inches. And if each puck is 1 inch high, then the height of this container would be 4 inches. And then we could just find the volume once instead of finding the volume of 1 puck and multiplying it by 4. But that would work as well. Okay, so if I find the volume, if this has 1 cylinder, it would be pi r squared h, our cylinder formula. So area of the circular base times height. Now the radius here is 1.5, half of the diameter. Okay, so when I type that in, I find out the volume is 28.27 cubic inches. Now it asks for the answer in cubic centimeters. So now we have to convert this to cubic centimeters. Okay, so again, if you look at your conversion chart, you'll see that 1 inch is approximately 2.54 centimeters. So that means that 1 cubic inch is equal to 2.54 times 2.54 times 2.54 centimeters cubed. So 1 cubic inch is 16.39 centimeters cubed. And that's helpful because now if I want to convert 28.27 inches cubed, if 1 inch cubed is 16.39, then I just want to multiply 28.27 by 16.39 to convert to centimeters cubed. So the volume of the package is about 463.3 centimeters cubed. So therefore the volume is at least 463.3 centimeters cubed. And that's the end of your lesson.